Gravitational potential energy is the energy contained within an object due to its position in a gravitational field. So floating in space in a zero-G environment, there's no potential energy associated with a object's position, but if an object is somewhere above the surface of the Earth, then it is containing potential energy that could be translated into kinetic energy upon its release, and then upon impact with the ground, it can release that energy in the form of heat, vibrations, and so on. So our equation for gravitational potential energy calculation for an object is listed there. So we have the mass of the object times the acceleration due to gravity, wherever that object is located, whatever planet or heavenly object. And then there's the height above the surface of that particular body. And then, of course, we need to include G sub c, so the proportionality constant that we've associated with our engineering English when our mass is given to us in the form of pound mass. We're going to use that 32.2 value as opposed to when we're in SI units or in the slug system, then we can just use that value as 1. So in our first example, we have Wile E. Coyote. It's holding an anvil of mass 100 pound mass at the edge of a cliff directly above the Roadrunner, 1,000 feet below. So we want to know what is the potential energy of the anvil in that circumstance. So if we go back to our equation with that 100 pound mass times acceleration due to gravity on Earth is going to be 32.2 feet per second squared. Our height is that 1,000 feet. And then, of course, with a mass given in pound mass, we're going to use our 32.2 pound mass feet over pound force second squared. And so our 32.2's cancel out in this case. We've done this enough times that hopefully we know the units are going to work out for us into foot-pound force. And so our answer rounded to 3 significant figures is going to be 1.00 times 10 to the 5th foot-pound force. And recall, we could report our answer in horsepower as well, but generally speaking, we'll limit ourselves to using foot-pound force as that energy label for engineering English. And in our second example, we torture ourselves with a little bit of dimensional analysis embedded into the problem. So now we're a climber with a mass of 200 pound mass that is standing atop Mount Everest at 29,035 feet. So we want to see what the potential energy of that climber is. We want that in joules as well as in pound force. So we'll start off with our answer in pound force since we're given engineering English units. So we've got our GPE is going to equal the mass, so that's 200 pound mass times the acceleration due to gravity times the height, 29,035 feet, and then of course divided by our 32.2 pound mass feet over pound force second squared. So if we crunch that out on our calculator, canceling out our 32.2's, we're going to end up with an answer of 5.81 times 10 to the 6th feet-pound force. So there's our answer in engineering English units. And so then we can use the same basis for our calculations. So if we go back to our GPE equation and just use a few unit conversions in there. So we've got our 200 pound mass. If we convert that to kilograms, recall that 1 kilogram is the equivalent of 2.20 pound mass. And then we can use our acceleration due to gravity, 9.81 meters per second squared. And then we've got our height, which is in feet. So we'll start there, but then we need another conversion factor, and so recall that it's 3.28, that's a 2 there, feet per meter, And so in this case, we do not need G sub C at 32.2 because we're converting everything into our SI units. So again, we're just in calculator button pushing mode territory. And so we can say that our answer is 7.89, again, to 3 significant figures, times 10 to the 6th joules. Or if we wanted to use a answer that's between 1 and 1,000, that would be 789. Since that's 7,890,000 joules, we can say that that's 7.89 megajoules would be the answer in that case. Would be 1,000, mega is the prefix for a million, so we've got 7.89 megajoules. We'll talk more about those types of prefixes in further units that we'll do later in the year. So for now, just putting an answer in terms of joules would be just fine.